Elon Musk has given us factory tours of Tesla's production lines many times, showcasing how cars can be built in just a matter of minutes. But now, the Tesla CEO has revealed a manufacturing breakthrough that could make dozens of traditional factories obsolete in the near future. A single Tesla could be produced in as little as 40 seconds. What's remarkable is that this time Tesla isn't unveiling a new vehicle, a next-generation battery, or even a humanoid robot. Instead, Elon Musk is aiming to reinvent the way the entire automotive industry builds cars, and that's what should truly worry legacy automakers. For more than a century, virtually every car manufacturer in the world has followed the same basic formula. Thousands of individual components are produced separately. Hundreds of robots weld them together. Then thousands of workers assemble each part step by step until a finished vehicle rolls off the production line. Tesla no longer wants to build cars that way. That's because Elon Musk's goal isn't to build a better car, it's to build a better factory. And if the factory becomes efficient enough, the cost of producing every vehicle will continue to fall. At that point, the real competitive advantage won't come from styling or marketing. It will come from the manufacturing process itself. So what's really happening inside Tesla's Gigafactories? Why does Elon Musk believe this new production system could change the game? And more importantly, how can Tesla actually build a car in just 40 seconds? For more than a century, the automotive industry has operated under essentially the same principle. A car is divided into hundreds, sometimes thousands, of individual parts. Each component is manufactured separately before being sent to the assembly line, where it is welded, bolted together, assembled, and inspected step by step. This process has been refined over decades, and nearly every major automaker in the world, from Toyota and Volkswagen to Ford and General Motors, still follows the same basic approach. But Elon Musk looked at that process and asked a surprisingly simple question. If dozens of smaller parts ultimately have to be joined together to form one larger component, why not manufacture that larger component from the very beginning? That seemingly simple question paved the way for one of the biggest manufacturing revolutions Tesla has ever undertaken. Instead of welding together dozens of small metal stampings to form a vehicle's frame like traditional automakers do, Tesla uses massive casting machines known as the Gigapress. Depending on the vehicle, these machines generate anywhere from 6,000 to 9,000 tons of clamping force, with future versions expected to reach as much as 50,000 tons. These enormous machines can transform molten aluminum into a single one-piece casting in just one shot. That means dozens of separate components and hundreds of welds can be replaced by a single structural part. At first glance, it may seem like nothing more than an engineering improvement. In reality, its impact extends across the entire manufacturing process. With fewer parts to assemble, far fewer robots are needed for welding. Tesla's Gigafactory Texas once relied on well over 1,000 robotic arms spread throughout the factory. But after introducing the Gigapress, the company was able to eliminate roughly half of its welding robots. Fewer joints also mean fewer opportunities for defects. A simpler production process translates into shorter manufacturing times, lower production costs, and vehicles that can be built significantly faster than before. This is exactly the kind of innovation that customers like us almost never notice, yet it has a direct impact on the final price of every vehicle. What's even more significant is that the Gigapress is only the beginning. Based on what Tesla has revealed at recent events, Elon Musk wants to push manufacturing even further with a revolutionary approach known as the Unboxed Process. Instead of moving a vehicle through hundreds of yards of assembly lines where each component is installed in sequence from start to finish, Tesla plans to divide the car into 6 independent modules. The front section can be assembled in one area, the rear body in another, the battery pack completed on its own dedicated production line, and the interior assembled simultaneously at a separate station. Rather than building the vehicle step by step, these modules are produced in parallel and brought together only during the final stages of assembly. Only in the final stage are all of these modules brought together to form a complete vehicle. According to Tesla, the numbers behind this manufacturing approach are just as impressive as the concept itself. The company says the unboxed process can reduce manufacturing costs by 50%, shrink factory floor space by 40%, and increase production efficiency and throughput by 30%. The most striking figure is the projected 50% reduction in manufacturing costs. By minimizing idle time, optimizing the use of robotics, and simplifying processes such as painting, Tesla aims to cut the cost of building its next-generation vehicles in half. The Cybercab is expected to be the first vehicle built using this production system. Elon Musk has said Tesla is targeting a manufacturing cost of around $30,000 per vehicle, with the potential for cost to decline even further as the process matures and production scales up. The Gigapress and the Unboxed Process are Tesla's two strategic weapons for the next generation of automotive manufacturing. While the Gigapress is already in operation, the Unboxed production system is still being refined and optimized. Tesla expects the process to be fully ready for large-scale vehicle production around 2027. But if the Gigapress is where Tesla creates its massive one-piece castings, the body shop is where those castings are transformed into the structure of a complete vehicle. Often described as the heart of the factory, the body shop is where automation reaches its highest level. Unlike the final assembly area, where humans and robots work side by side, the body shop is dominated almost entirely by robots. Hundreds of robotic arms operate around the clock, 24 hours a day, moving with extraordinary precision as they perform thousands of welding operations on every vehicle body. Spend just a few minutes in this section of the factory and it's easy to understand why Elon Musk once described a Tesla factory as the machine that builds the machine. Every movement is programmed, synchronized, and timed down to the second. Once the components are precisely positioned, Tesla's robotic systems use multiple joining techniques rather than relying solely on traditional welding. Resistant spot welding secures the sheet metal at thousands of critical points throughout the vehicle's body structure. Laser welding is then used in areas that demand extremely high precision, producing cleaner welds with greater strength and a more refined finish. In addition to welding, Tesla also uses high-strength structural adhesives, industrial-grade bonding materials that significantly increase the body's torsional rigidity while reducing vibration and road noise. By combining several advanced joining technologies, Tesla is able to build a vehicle structure that is both stronger and lighter than one assembled using conventional all-metal welding alone. This engineering approach is also one of the key reasons Tesla vehicles consistently achieve top safety ratings in crash tests, providing a rigid passenger cell that helps absorb and distribute impact forces more effectively. One of the biggest advantages of robots isn't just speed, it's consistency. A highly skilled technician can produce exceptional work, but after hours of continuous labor, small variations are almost inevitable. Robots are different. They can repeat the exact same motion thousands of times with virtually no loss of precision. That level of repeatability ensures that every vehicle body leaving the body shop meets the same quality standard, creating a solid foundation for every production stage that follows. It's also why Tesla is willing to invest millions of dollars in robotic systems for manufacturing tasks where machines can consistently outperform humans. Even after leaving the body shop, however, the vehicle is still far from complete. The body is then transferred to the paint shop, one of the most demanding and tightly controlled areas in the entire factory. Here, even a single microscopic speck of dust can ruin the paint finish and force the entire body to be reworked. That's why every stage of the painting process takes place in an environment where temperature, humidity, and air cleanliness are carefully monitored and controlled to exacting standards. The process begins with a thorough cleaning of the vehicle body to remove any dust, grease, or residual contaminants left behind during manufacturing. Next, the body is submerged in an electrophoretic deposition bath, more commonly known as e-coating. This process applies a uniform anti-corrosion coating across every exposed metal surface, including hard-to-reach areas that conventional spray guns simply can't access. It's one of the most critical stages of the entire paint process, providing long-term protection against moisture, road salt, and corrosion throughout the vehicle's lifespan. After the corrosion-resistant coating comes the primer, which creates a strong bond between the metal body and the exterior paint layers. Only after these foundation layers are complete do robotic paint systems begin applying the vehicle's color coat, followed by a clear protective top coat. Every step is fully automated to ensure the paint thickness remains remarkably uniform across the entire vehicle. The painted body is then transferred into a curing oven, where precisely controlled temperatures allow each layer to harden completely. The result is a smooth, glossy finish that is both highly durable and designed to withstand years of exposure to the elements. There's an interesting detail that many people don't know. The paint shop is one of the few areas where multiple Tesla models share the same production line before branching off into their own dedicated assembly lines. The Cybercab, however, is expected to be the exception. Instead of painting the body after it's cast, Tesla plans to integrate the color and protective exterior finish directly into the large casting process, eliminating the need for a conventional paint shop altogether. The reality is that competition in the EV industry is no longer defined solely by battery range or acceleration. The real battle is being fought over manufacturing costs. The company that can build a vehicle at the lowest cost has the greatest flexibility to cut prices, expand market share, and continue investing in new technologies. Tesla has demonstrated this strategy repeatedly by adjusting vehicle prices across multiple markets, putting enormous pressure on its competitors. And if its next-generation manufacturing system performs as planned, the cost advantage between Tesla and the rest of the automotive industry could grow even wider. Ironically, though, there's one part of this story that often goes overlooked. Elon Musk himself once suffered a major setback after trying to automate Tesla's factories too aggressively. In 2018, as Tesla ramped up production of the Model 3, Elon Musk set an ambitious target of building 5,000 vehicles per week. To achieve that goal, he pushed factory automation further than almost anyone in the automotive industry had attempted before. Hundreds of robots were assigned to perform tasks that humans had traditionally handled very well, from routing wiring harnesses and installing interior components to transporting parts between workstations. On paper, the idea sounded perfect. In practice, it turned out very differently. The robots excelled at handling rigid, precisely defined components, but they struggled with soft, flexible materials such as wiring harnesses and insulation. If even a single part was misaligned by a few millimeters, it could disrupt every operation that followed. As a result, the production line experienced repeated stoppages, and actual output fell far short of Tesla's ambitious targets. Elon Musk later acknowledged the mistake in a post on X, writing, "Excessive automation at Tesla was a mistake. To be precise, my mistake. Humans are underrated." It remains one of the few occasions on which Musk has publicly admitted that he had taken the wrong approach. But that failure ultimately taught Tesla one of its most valuable manufacturing lessons. Robots are not the goal. Efficiency is. If people can perform a task faster, more affordably, and more reliably than a multi-million-dollar robotic system, then there's no reason to automate it just for the sake of automation. From that point on, Tesla began redesigning its entire manufacturing system around a simple but highly effective principle. Use robots where they clearly outperform humans and rely on people where human flexibility matters most. Today, robots are assigned to the jobs they're best suited for heavy, repetitive, and highly precise tasks such as welding, lifting vehicle bodies, transporting large assemblies, and producing one-piece castings with the Gigapress. Meanwhile, human workers continue to handle operations that require adaptability, dexterity, and real-time decision-making. During the Model 3 production ramp, Musk had believed that adding more robots would automatically make the factory faster and more efficient. Robotic arms replaced human workers across a wide range of manufacturing tasks. On paper, it seemed like the perfect strategy. After all, robots don't get tired, don't need breaks, and can perform repetitive motions with remarkable precision. But reality proved far more complicated. When a single robot malfunctioned, every process downstream could come to a halt. At times, Tesla even had to wait for replacement parts to arrive from overseas while thousands of unfinished vehicles sat idle on the factory floor. Elon Musk later publicly admitted that he had overestimated what robots could do and underestimated the flexibility and problem-solving ability of human workers. It was an expensive lesson, one that fundamentally reshaped how Tesla designs and operates its factories today. Rather than pursuing automation for its own sake, Tesla now focuses on building manufacturing systems where humans and machines each perform the tasks they do best, maximizing efficiency across the entire production process. 10 years ago, solar power was an expensive dream reserved for billionaires. Today, it's the cheapest source of electricity in history. For years, the world believed that making solar energy more affordable depended on scientists developing more efficient panels, better materials, and increasingly advanced technologies. But the truth that's now emerging is very different. Today's solar panels are already efficient enough and affordable enough, thanks in large part to AI-powered robots. Tesla is also planning to build what could become the world's largest solar manufacturing facility, with a production capacity far beyond what most people can imagine. What you're about to hear is truly fascinating. As we mentioned earlier, if you look back just 10 to 15 years, building a utility-scale solar farm was something only major corporations or governments could afford. Solar panels were extremely expensive, manufacturing capacity was limited, and every project required investments worth billions of dollars. But everything has changed at an astonishing pace. Driven by massive economies of scale and continuous technological improvements, the cost of solar panels has fallen to levels that were once considered almost unimaginable. As of 2025, the installation cost for a utility-scale solar power system in the United States ranges from 95 cents to $1.23 per watt. For a 1 megawatt utility-scale solar farm, the estimated cost is approximately $980,000, excluding land acquisition. That works out to a total installed cost of about 98 cents per watt. In many countries, solar power has already become the cheapest new source of electricity to build. Yet one question continues to puzzle many people. Why hasn't the overall cost of solar projects fallen even faster? The answer lies in a task that seems deceptively simple but accounts for a significant share of a project's total cost. A utility-scale solar farm can require hundreds of thousands or even millions of solar panels. Every single panel must be transported to its exact location, lifted onto the mounting structure, carefully aligned and securely fastened with bolts. This process has to be repeated millions of times. Not only does it require a massive workforce, but construction also takes months under harsh weather conditions. In the end, labor, transportation, and lengthy installation times, not the solar panels themselves, have become the biggest factors preventing the cost of solar power from falling even further. That's why the energy industry is beginning to witness a transformation unlike anything we've seen before. Instead of squeezing out another percentage point of solar panel efficiency, technology companies are now focusing on automating the entire construction process. A 9-ton AI-powered tracked robot developed by Terabase Energy has been built with one purpose: installing solar panels. Unlike the multi-purpose machines of the past, this robot is designed to perform a single task, and because of that, it can do it with a speed and level of precision far beyond what humans can achieve. The robot moves autonomously across construction sites using a tank-like track system. Equipped with advanced AI and an array of sensors, it can navigate rough terrain, identify the exact location of each mounting structure, lift solar panels weighing dozens of kilograms, and place them precisely where they need to be installed. It operates around the clock without breaks and is unaffected by extreme heat or harsh working conditions. Most importantly, the robot dramatically reduces the need for manual labor, which currently accounts for a significant portion of the total cost of building utility-scale solar power plants. By replacing thousands of hours of manual work with an automated system, developers can substantially lower the cost of each project while dramatically shortening construction timelines. According to estimates, this robot could reduce the installation cost of utility-scale solar farms by around 30%. That's one of the biggest reasons why the cost of solar power is now falling faster than ever. China has also begun deploying robots on a large scale across the solar industry for both installation and maintenance. Some cleaning robots are even equipped with integrated solar panels, allowing them to operate autonomously. One Chinese company, Lepting, used robots to build a 350-megawatt solar farm in Australia. According to the company, each robot can perform the work of 3 to 4 people, but much faster. Their long-term goal is to fully automate the construction of solar farms. This is more than just another step forward in automation. It could be the final piece of the puzzle that propels solar power into an entirely new era. As installation costs continue to fall, projects can be completed more quickly, built at larger scales, and deployed across more countries. That in turn means the cost of clean electricity will continue to decline, putting tremendous pressure on traditional energy sources. Interestingly, just as robotic technology is beginning to reshape the solar industry, Tesla is quietly preparing an even more ambitious plan. To most people, Tesla is still the world's largest electric vehicle company. But for Elon Musk, electric cars were never the ultimate goal. For years, he has repeatedly said that Tesla's real mission is to build a complete energy ecosystem, one in which electricity is generated by solar power, stored in batteries, and used to power not only vehicles but the cities of the future as well. While the public remains focused on robotaxi, Optimus, and AI, Tesla has been investing heavily in the energy sector. According to publicly available information, the company is developing a massive solar manufacturing facility in Brookshire near Houston, Texas. The project is envisioned as a vertically integrated production hub where multiple stages of the manufacturing process, from silicon processing and solar cell production to final panel assembly, will all take place within a single complex. What has especially caught analysts' attention is not just the scale of the facility but the long-term production targets Elon Musk has discussed. According to the available information, Tesla aims for an initial production capacity of around 100 gigawatts of solar panels per year, with the ultimate ambition of expanding to terawatt-scale manufacturing in the future. If achieved, it would represent a dramatic leap beyond the company's current production capabilities. But Elon Musk understands that simply manufacturing more solar panels isn't enough. If installation in the field still depends on millions of hours of manual labor, the pace of deployment will always be limited. That's precisely why the emergence of AI-powered construction robots is so significant. On one side is enormous solar manufacturing capacity. On the other is the ability to build solar farms faster and at a much lower cost through automation. When these two trends come together, the energy industry could enter an entirely new era of growth. If there's still any doubt that Tesla is truly serious about the energy business, the company's latest second-quarter earnings report speaks for itself. In just 3 months, Tesla deployed a total of 13.5 gigawatt-hours of energy storage systems, a 41% increase compared with the same period last year. It was also the second-highest quarterly energy deployment in the company's history. These numbers make one thing clear. Tesla no longer sees energy as merely a business that supports its electric vehicles. Instead, it is becoming one of the company's primary long-term growth pillars. What's particularly noteworthy is that even though the energy division's gross margin fell from 39.5% to 20.4% due to tariffs and higher operating costs, Tesla has continued expanding its investments rather than scaling them back. This is a strategy Elon Musk has employed many times before, accepting lower short-term profits in exchange for gaining a long-term advantage through scale. That very strategy transformed Tesla from a small electric vehicle startup into the world's largest EV manufacturer. Now Musk appears to be applying the same playbook to the energy business. At the same time, Tesla's Shanghai Megafactory continues to ramp up production, achieving record Megapack deliveries across the Asia-Pacific region. Meanwhile, the Texas Megafactory has entered its commissioning phase, with plans to begin manufacturing Megapack 3 and Megablock systems later this year. This means Tesla isn't just aiming to manufacture more solar panels. It also wants to build energy storage capacity on a scale the industry has never seen before. Elon Musk understands one fundamental truth: a solar panel only generates electricity when the sun is shining. A robust energy storage system is what transforms renewable energy into a reliable power source available 24 hours a day. That's why Tesla is developing all three critical pieces of the puzzle at the same time: power generation, energy storage, and automated deployment. AI-powered robots dramatically reduce the cost of building utility-scale solar farms. Megapack systems store the enormous amounts of electricity those solar farms produce, and solar manufacturing facilities capable of producing hundreds of gigawatts worth of panels each year will supply the equipment needed to scale the entire ecosystem. But Tesla's ambitions extend far beyond solar energy. The company is also building a dedicated AI chip manufacturing facility in Austin to accelerate the design and testing of next-generation processors. Over time, Tesla plans to establish an increasingly self-sufficient supply chain for AI logic chips, memory, and advanced packaging technologies. Another project, known as Terafab, has also been confirmed by Elon Musk, who said it will be unveiled at a dedicated event. The project is widely viewed as a key part of Tesla's strategy to manufacture AI chips for its full self-driving platform, the Optimus humanoid robot, and the powerful AI supercomputers that will train future generations of artificial intelligence. When you put all of these pieces together, the bigger picture finally comes into focus. AI-powered robots slash the cost of building utility-scale solar farms. Massive solar manufacturing facilities produce clean electricity on an unprecedented scale. Megapack and Powerwall systems store that energy. And AI chip factories provide the computing power needed for self-driving vehicles, Optimus robots, and the entire intelligent ecosystem Tesla is building. This is no longer just the story of an electric vehicle company. It's the story of Tesla's ambition to control nearly every link in the future value chain of the energy and artificial intelligence economy. But even if AI robots can dramatically reduce the cost of building solar farms, one question continues to be raised by critics of renewable energy. If millions of solar panels cover vast stretches of farmland, won't valuable agricultural land be lost? Interestingly, a large-scale project in New South Wales, Australia, is proving the exact opposite. Rather than replacing agriculture, solar power is actually helping farms become more productive than ever before. At New England Solar Farm, one of Australia's largest solar projects, more than 6,000 merino and crossbred sheep graze beneath approximately 1 million solar panels. Once the project is fully completed, the site will feature around 1.5 million panels with a total generating capacity of 720 megawatts, enough to supply electricity to roughly 300,000 homes. What's truly remarkable is that livestock farming hasn't just continued alongside the solar installation, it has actually become more productive. According to the farmers involved in the project, the solar panels have created a highly beneficial microclimate. The shade cast by the panel arrays helps the soil retain moisture longer after dewy nights, allowing grass to stay greener and grow more vigorously despite Australia's hot, dry climate. During the summer, the sheep have shelter from the intense sun, significantly reducing heat stress. In winter, the panels act as a protective barrier, shielding the animals from frost. As a result, the sheep are healthier, wool quality has improved, and some farmers even report that they can raise more sheep on the same amount of land than they could before the solar farm was built. The benefits don't stop with the farmers. Energy companies also save on maintenance costs because the sheep continuously graze beneath the solar panels, naturally controlling vegetation, reducing wildfire risk, and minimizing the need for mowing or chemical herbicides. Rather than competing with agriculture, solar power is creating a mutually beneficial partnership in which both industries thrive. For farming families, the financial benefits are equally significant. In addition to income from livestock, they receive long-term lease payments for allowing their land to be used for solar development, often under agreements that last for decades. This provides a stable and predictable source of revenue, helping shield them from fluctuating agricultural commodity prices and prolonged droughts. Many families say this dependable income has enabled them to keep their farms in operation and pass them on to the next generation. This may well be the final piece of the puzzle Elon Musk has been working toward all along. If AI-powered robots can dramatically reduce the cost of building solar farms, and projects like New England Solar Farm prove that agricultural land can continue generating value, then one of the biggest obstacles to expanding solar energy has all but disappeared. Tesla is investing in solar panel manufacturing, megapack energy storage systems, artificial intelligence, and automation to build a fully integrated energy ecosystem. As manufacturing costs continue to decline, installation becomes cheaper through AI-powered robotics, and farmland serves both agriculture and electricity generation at the same time. Solar power will no longer be just a clean source of energy. It will become a more compelling economic solution than ever before. Perhaps that's why the debate of the future will no longer be solar power or agriculture. The answer is becoming increasingly clear. Solar power and agriculture can thrive side by side. The fields don't disappear beneath the solar panels. Sheep continue to graze and flourish. Farmers gain a reliable new source of income, and the world gains more clean electricity at an ever lower cost. This is the truly sustainable model that many countries are now pursuing, and one of the key reasons the global solar energy revolution is accelerating faster than ever before. That's all for today's deep dive into solar power. If you want to keep exploring how Tesla builds the future, hit like, subscribe, and join us for the next engineering breakdown. Goodbye.